Hi there, everyone. It's me, Tim Dodd, the Everyday Astronaut, and welcome to my coverage of NASA slash NOAA's GOES S launch. And now this is launching on top of a mighty Atlas V rocket made by ULA, which is United Launch Alliance. That's a joint venture between Lockheed Martin and Boeing. And this is an Atlas V in the 541 configuration. And the Atlas V really, I mean, I don't even know why they have we'll talk about the numbering. There's the 541. 5 means 5 meter the fairing, which is the bigger of the two fairings. They can either do a 5 meter or a 4 meter fairing. The 4 in that number, the 541, is the number of strap-on solid rocket boosters out of a potential 5. So they can have as few as 0 solid rocket boosters, and they can have up to 5. This one has 4. So this is a pretty big. This is almost as big as the Atlas V will get. And then the 1, the nomenclature 1 at the end is a funny one because so far of the 75 Atlas V launches to date, they've only ever used 1 engine in the Centaur upper stage, even though it has the potential to do 2, which would be 2 RL-10s on the Centaur upper stage. But for whatever reason, they've always just, they no matter what, name it like 541, even though so far I've only ever seen the 5 or the something 1. We've never seen a something 2. But that being said, okay, so this is launching from Cape Canaveral, Cape Canaveral Air Force Station, to be exact, out of Slick 41 or Space Launch Complex 41. It's right next to SpaceX's Launch Pad 40, so Slick 40. It's in between Slick 40 and Historic 39A, kind of right in between those two almost, a little bit more north. Yeah, so that's where it's launching from. It's sending a, 5,200 kilogram satellite up to geostationary transfer orbit. And that's about 11,488 pounds. This is a satellite made by Lockheed Martin. It's a weather observation satellite. It's the twin kind of to the GOES R satellite that launched in November of 2016. So it's basically the same thing, but this one's going to be covering more of the western hemisphere, or western half of the United States, and out all the way to Hawaii. The other one, covers the eastern half of the United States and more out to the Atlantic Ocean. And what they do is they observe weather patterns, so clouds and typhoons and things like wildfires and fog. And the fog is like, who cares about fog? Just look outside and go, it's foggy out. Here's the deal. I didn't realize this when reading up on this. Fog is a big deal for things like airports. If they have resolution of only seeing a 10-mile or 16-kilometer pixel, basically says, "Ooh, it's foggy here," you might delay everyone's travel, or even worse, say it's okay to fly in that thick fog when it might not be. So this increases the resolution by 10 times almost compared to what we've been using lately. So this will help have safer and or maybe even potentially quicker and more reliable air travel as well. So this is a good thing. It's a cool satellite. It's huge. It's really big. When you see it next to people, hopefully they show some cool shots. So yeah, so this, again, guys, you're going to have to forgive me a little bit here. This is the first time I've done a live launch of for ULA, or a non-SpaceX launch. And people often are like, oh, you're a SpaceX fanboy. The reality is I just know the most about SpaceX. I'm most familiar, most comfortable talking off the cuff about SpaceX, even though I've been to 4 ULA launches. I've seen an Atlas V launch. You know, I get it. I know them, but I'm just not as... They do things that are funny procedures to me, and I'm just not as in-depth. So I might be having to reach out to you guys in the chat to maybe help answer questions if I don't know them. But yeah, hopefully it goes well. You guys have been asking me to do this, so this is for you guys. Hopefully we can help answer questions for other people too. So, hey there, Chris. Sometime in school, people bully you and call you Rocket Boy, but here you feel welcome. You can talk to people who know what I mean when we talk, so thank you. Well, thank you, Chris. Rocket Boy is an all-time compliment in my book. Those people will be laughing when you have an awesome job working for an awesome space company making cool things go to space, and they're reliving their glory days of playing football. Sorry, that that may or may not be the case. Maybe the football players will become rocket scientists too. Actually, I have a good friend that was a football player that's a rocket scientist. So, yeah, nothing against football players. But yeah, hopefully Rocket Boy is a compliment here to come instead of some kind of insult. How is everybody doing? A joint venture of the War Machine. NASA is flat. Oh, that's funny. So yeah, so we have a lot of people saying, why is it that, why don't they recover the rocket? Why doesn't ULA work on recovering the Atlas V? Well, the Atlas V, I mean, for 100% sure, the Atlas V is incapable of recovery. You have to design a vehicle around recovery. You can't just be like, let's recover this one that's already flying. One of the biggest reasons they couldn't do that, the Atlas V only has a single engine, two-chamber single engines, the RD-180, which is a derivative of the Soviet RD-170, which is actually the most powerful rocket engine ever made. Forget the old F1 Aerojet Rocketdyne engine on the Saturn V. The RD-170 technically has a little bit more thrust. It's 4 chambers. They basically cut it down to 2 chambers and shrunk the turbo plumbing and turned it into a more of a workhorse, more suitable for a standard launch vehicle like this. And that one engine or 2-chambered engine cannot go anywhere near low enough thrust potential to do any kind of landing. If we think about how SpaceX has to do a hover slam or a suicide burn, because their thrust to weight ratio is above that 1-to-1 ratio, meaning that even down to, so they have 9 engines on a Falcon 9, and they're just down to a single engine at the final bit, and even at that single engine decreased to 40% throttle, it's still too powerful to hover. And so that means they really have to be controlled about when they start and fire up that engine. Now imagine trying to do that on an engine that can only throttle to 40% out of the entire thing, not divided by 9. Yeah, so they can't propulsively land it. It's not made to be recoverable. And it is kind of sad that we still are seeing non-recoverable or not even attempts to recover. ULA has basically stated that they have no intentions of working on full reusability. They have a feature in their upcoming Vulcan rocket where they hope to detach the engines and parafoil do an inflated heat shield and then parafoil and swoop them up and pick them up by a helicopter. But we might not, if they do choose to pursue that, they won't pursue that until something like 2024. And by then, I think we might see BFR online. We'll definitely see Blue Origin's New Glenn. I mean, in my opinion, like they gotta step up if they want to really be able to compete. And so far, they are more expensive than SpaceX. And the reason again we're talking about this is because these are the numbers that people seem to care about. But don't forget they've been around the longest, and they have so far with the Atlas V, it's 100% success rate. It had one partial failure for OA6 and another one in one of the earlier flights, like that 7th flight or something, had a partial failure, but it still made it into orbit. And a lot of that's due to its upper stage. That Centaur upper stage on top of the Atlas V is a absolute beast. It's cryogenics that uses liquid hydrogen and liquid oxygen. It has a lot of flexibility in its orbits, and you'll actually see that today. It will do 3 burns to put this thing into space. And that's some of the reason, because of how awesome that upper stage is. They have a little bit of flexibility in their time to launch. So I think today we have a 2-hour window, and what they do is they'll basically pre-program different holds and say like, okay, if we hit this T-0, this is what the trajectory will look like. And most of the time it's making an inclination change using that upper stage kind of at apogee. So the upper stage will do an extra burn to correct for wherever it is on course. So yeah, I think, yeah, so today, Mini Hick in our Discord, you're right. I should not have said the S word burn. I should have only said hover slam. Otherwise, the demonetization will hit up. So, all right. So, yeah, nothing is known publicly about New Armstrong. That's correct. Good job, Arco. So, Blue Origin does have another vehicle that will be bigger than New Glenn, called New Armstrong. And notice Blue Origin's, their nomenclature, their naming scheme goes like this. There's the New Shepard after Alan Shepard, the first suborbital flight from the U.S. That's cool. So their suborbital vehicle is called the New Shepard. Then we have the New Glenn, and John Glenn was the first American to orbit. So therefore, the New Glenn is the orbital vehicle. And then there's the New Armstrong, which, as we know, Neil Armstrong was the first person to walk on the moon. So their New Armstrong vehicle is a moon class, much bigger, huge moon rocket sized, super heavy lift vehicle that they've only teased. But we do, I take them seriously. Hey there, Tuba Horse. Thank you. I am doing well. Oh, I'm glad that you could catch it before work today. Hope that that goes well. Thank you for the tip. And hi. So I'm waiting here, guys. I've got NASA pulled up their stream. I think they're going to have a live stream of this today, hopefully. Otherwise, we might be scrambling. We might be scrambling for a... Oh, here we go. Yep, next in about 3 minutes. I'll hopefully be able to pull up the live stream here. So, in the meantime, is there any other questions you guys have? Philip James, yes, you're correct. It sounds like the new Armstrong would be some kind of close to that BFR capability. I don't know if it'd be quite BFR capability. So, and that's one of those things. Even it's hard to compare apples to apples, guys, because we get different quotes from different people and different companies. For instance, we believe actually the numbers that they're publishing for New Glenn is only in reusable mode. I don't think they're planning to ever expend or ever, throw away a New Glenn rocket. It doesn't seem like that's in their business plan. And so therefore the numbers they quote are only reusable, which if you match reusability compared to the Falcon Heavy full reusable, it looks like they're almost the same performance. So really the New Glenn, people were, even I was saying, I thought it was kind of between a Falcon 9 and a Falcon Heavy, but it really seems like it's going to be closer and very on par with a fully reusable Falcon Heavy. Falcon Heavy, though, they quote it an expendable. So with that 63,000 kilograms to orbit, that's an expendable mode. So realistically, it sounds like if you're doing full reuse, you can expect around half that. We're guessing around 30,000 kilograms. And that's about exactly what we think New Glenn can do. So, Paul, did I go to college? Yeah, I went to college. Did I do anything in college is the real question. The answer to that is no. I dropped out a few times. I failed out a few times. I was not good at college at all. And I mean, the funniest thing is I was like a good kid. I kind of occasionally went to class. I didn't even party in college or anything like that. It wasn't anything like that. The academic setting just kind of killed me. I couldn't do it. And I really didn't do that great in high school either. I've always liked to learn on my own and learn my own things. And I don't know if it's like a authority problem or something. I don't know. Like my parents would always laugh that if they could tell me to do something 100 times and they'd say, oh, we'll tell you like it, but I wouldn't like it until I experienced on my own. So maybe it is some of that. Yeah. And that's just the way I've learned anything about rockets is on my own. I don't know. And photography, self-taught photographer, self-taught musician. That's the way I personally learn. So if you can do academia, please do academia. Renaud, thank you for the tip. We'll have fun at work. Hopefully rewatch this live stream or the live stream or the NASA official one. Hopefully it goes all well. So, Andrew Church asks, wow, this is built into YouTube. How much do I get? I actually don't know the answer to that, to be honest. This stuff, the super chat stuff is still relatively new to me. I think a percentage of it. I don't know what percentage. I don't know, but thank you. Let's see here. Sorry. Yeah, Timu asks if I drew these. My background. Yes, I did. We'll hopefully see more of that in the future. I whipped that up. I bought a chalkboard and drew that stuff up quick. That's actually my original kind of art form when I was growing up was drawing. I love drawing. And then I took to photography later, but my medium, still probably my best and most comfortable medium is drawing. I just love to sketch. I'm not very good at it, but I like to do it. Let's see. Pronounce your name correctly. Howdy. Is YouTube my main job? So yes, no, I don't have any other job anymore. I committed to doing Everyday Astronaut full-time as of 2017. I had 2 more. So I had been doing mostly wedding photography and other commercial and, gigs like that. In 2017, and I committed last year to no longer booking anything and pursuing Everyday Astronaut full-time. There's some exciting things coming on. It's not all going to be YouTube. There will be some other things that I've been working on since last year that I still can't talk about, but I've taken to trying to do education and outreach full-time. It just now finally, come October, I was sitting there going, there's no way I'll be able to make this into, I won't be able to do this anymore because I'm losing money doing it. But thanks to the support of Patreons, thanks to the tips you guys get, It's sustainable, and I don't feel like I'm going to totally lose my shirt and or my house to continue to do this. So thank you guys. You literally make it possible. How old am I? I'm 33. When is it launching? It's launching in 34-ish minutes. I believe the time is 5:02 Eastern, which is 22:02 UTC. Here we go. We have the NASA live stream has begun. Let me totally get it pulled up here for you guys.
Is on Cape Canaveral Air Force Station.
And the ASOC overlooks Space Launch Complex 41, where the Atlas V rocket is poised for liftoff at 5:02 p.m. Eastern Standard Time.
Inside of the ASOC, NASA Launch Manager Tim Dunn and United Launch Alliance Launch Director Tom Heater are working closely with the entire launch teams as we continue to count down to liftoff.
The launch teams began arriving on console this morning, and they've been working through launch procedures since then. The team received a weather briefing from the U.S. Air Force 45th Space Wing Launch Weather Officer Clay Flynn. The weather folks take a look at all kinds of constraints, luckily none of which we have to deal with today. They look at wind speed, cloud coverage, the potential for thunderstorms or lightning in the surrounding area, and even solar weather, which launch teams need to know before committing to launch. But as you see, we have a 90% go weather forecast with only a 10% probability of violating the launch constraint of cumulus clouds. Launch Weather Officer Clay Flynn is not concerned about that at this time. Winds are 20 to 25 knots from the west-southwest, temperature of 80 degrees, and we have a go forecast at this time for launch.
Right now, you're looking at a live view of the launch pad and the Atlas V and its 541 configuration. The Atlas V is a two-stage rocket, and the number 541 indicates a couple of key features about the rocket that will power NOAA's GOES weather satellite into orbit.
The 5 indicates a 5-meter fairing. Inside that protective cover is where the weather satellite is safely tucked away for launch. The 4 indicates the number of solid rocket boosters attached to the rocket's core, and the 1 indicates a single-engine Centaur upper stage rocket. Thus, the 541, one of the most powerful rockets in the Atlas V fleet.
Yesterday, February 28th, the Atlas V rocket, along with NOAA's GOES weather satellite, was moved from the United Launch Alliance Vertical Integration Facility, or VIF, to the launch pad.
The Atlas V rocket segments make their way to the Cape over land and water. The large Atlas booster and the Centaur second stage arrive on a boat called the Mariner. The Atlas rocket booster, the upper stage called the Centaur, the solid rocket boosters and the satellite, already encapsulated inside the protective fairing, are built up vertically over a series of weeks. The rocket, fully mated, rolled on the mobile launch platform to the launch pad yesterday.
There's less than a mile between where the Atlas rocket is fully built up and where the pad will launch the rocket. Still, the roll takes about 30 minutes. Afterward, the rocket was secured into place and technicians fueled the Atlas booster with RP-1, a rocket-grade kerosene, and completed all service connections from the launch site to the rocket. These connections provide power, fuel, and more to the rocket and spacecraft prior to launch.
Today, the crew began...
So I have a lot of questions. We've talked a lot about this, so I'm going to actually mute that until we get a little closer, because we've had a lot of good questions that I don't think they'll talk about, that I'd rather talk about specifically. First off, Trevor Miller, thank you for the tip. And thoughts on the Falcon 9 fairing pressure delays. New fairing, they're just playing it safe, making sure everything's okay. Not a big deal. Just like every time there's a new fancy thing on any rocket, plan on there being delays, because they just really want to play it safe. So... first off, okay, people are asking about the 5 meters. That is how wide that fairing is. These are huge. Don't forget, this is, you know, over, what is it? 5 meters would be like over 15 feet wide. It's a big fairing. It's very tall, and it actually encapsulates over half of the upper stage too, which is really strange. I don't actually know why they do that. It seems like they have a lot of fairing protecting just the upper stage. It seems like a lot of extra dead weight to me, but it is a huge, massive, massive fairing. One thing to keep in mind, guys, is this rocket is almost the same width, actually, believe it or not. Same diameter during the base of the booster and everything as the Falcon 9. It's only a tiny, tiny, tiny bit wider. So in comparison, the Falcon 9 is super tall. It's a good 10 meters taller, I believe, which again, 30-some feet. It's big. So yeah, so that's kind of the comparisons. People are asking what these white towers are here. Those are lightning towers. So that ensures that those are well-grounded towers. That ensures if there is lightning strike. Don't forget, Florida is actually one of the lightning capitals of the world, actually. Which, you know, lightning plus rocket and highly explosive materials, not a good thing. Very not a good thing. So those protect the vehicle while it's out on the launch pad from being hit by lightning. So the lightning is more attracted to those than it is the rocket, hopefully. And ta-da. ULA does not do any recovery of anything. This is a fully expendable vehicle. Yeah, so that's one of the reasons, guys, obviously, that SpaceX has become so exciting. Is because you get more out of the mission almost. Like us observers, us casual. By the way, guys, I've stood right there next to an Atlas V once while I was on the pad. It was awesome. You don't get a sense for how big this stuff is until you're right there and, you know, able to touch everything. It's crazy. They're big pieces of hardware. But yeah, that's so someone asks, why does SpaceX want to try to recover the fairing? You know, ULA is obviously not worrying about it. Well, it's still a $6 million piece of carbon fiber. It's still, you know, it's anything space grade is, you know, manufactured out of the most precise and expensive and perfect parts. You know, it's expensive stuff. So obviously, if you have $6 million falling out of the sky relatively intact, it makes sense to try to recover and reuse that. And oddly enough, they're kind of doing something similar to how SpaceX plans to, SpaceX is planning to recover, similar to how ULA wants to recover their engines eventually on the Vulcan rocket, which is re-entering. The engines would need to have an inflatable heat shield, but then do a parafoil and then coast and then be swooped up by a helicopter. SpaceX looked at doing fairing recovery with a helicopter, but they're trying to just land it down that Mr. Stevens boat. So you endorse metric units. I think we all should endorse metric units. Maybe this new space era will get enough people in the United States excited about metric that we just finally officially adopt the metric system in the United States. Wouldn't that be fantastic? How does it fly straight with 5 boosters? That's a great question, OD97. So this particular rocket has 4 solid rocket boosters. It's up to 5, and they can fly it with no boosters as well. It does not need boosters to get off the ground. But it does have asymmetrical boosters. And if you want a good video on that, Scott Manley on YouTube does an awesome video explaining asymmetric thrust. But basically what they do is the solid rocket booster kind of pitches out a little bit. And then the rocket kind of has to counter against that. So it almost drifts off the pad a little bit. And then eventually, you know, that becomes minimal later on. But yeah, they're asymmetric thrust. Even today, they aren't, like even in a 4 configuration, it's slightly asymmetrical for whatever reason. It's just interesting. I think it's mostly to avoid the big raceway that goes down the edge of the rocket. So why ULA rather than SpaceX? Cost, reliability. Thank you, Jacob, for the question. That's a good question. There's a lot of considerations when launching an expensive multi-billion-dollar. You know, these are high-end, very expensive, you know, not commercial, but weather satellites. Some of it could have been still, this might be a size 5,200 kilograms is darn close to the maximum payload of a Falcon 9, even expendable. And maybe they didn't plan on, you know, Falcon Heavy. I don't actually know their choice. Reliability certainly plays in when you're talking about $1 billion satellite. I don't know the exact reasons why they chose this rocket, but they did. And I don't exactly know why, but obviously, guys, ULA obviously still has a business case, or else they wouldn't exist. The free market would take them over pretty quickly. Granted, they do have a lot of government subsidies, and they do have pretty thick pockets for the Department of Defense and things like that. And most of it's based on their track record, the reliability. So, yeah. This is the larger fairing diameter. This is the 5-meter fairing diameter. When did they design this rocket? Horine. Dang it, I still never know how to spell it or pronounce it. Hey, thank you there, Pump85 in Discord. Thanks for becoming a Patreon member. So, Horine, Heroine, I'm just going to call you Van. Van Noonan asks, when did they design this rocket? It's been involved since the 60s. The Atlas so the Atlas V wasn't an Atlas V, it was just called the Atlas rocket. And what's crazy about it is it used to have 3 engines. So it was a 1.5 launch configuration at the beginning. So the two of the engines would actually cut out, because at the time they didn't quite know how to stage a rocket. They were nervous about trying to ignite an engine, in flight. It seems difficult. It is difficult. You have to either do a hot fire like the Soviets and the Russians do, or did and do, sorry. Or you have to use like ULA motors that can accelerate the vehicle to kind of catch the fuel so you can relight the engine. Otherwise, if you try to ignite the engine while it's in, while it's coasting, while it's in free fall, that fuel's not anywhere near the pumps. You can suck up a lot of air. It's called cavitation. It's not a good thing. It's not a good day. So what they did initially was they just dropped off 2 of the engines and let the center engine be a sustainer motor that was a little bit more vacuum optimized as well. And then eventually they evolved it. They added this upper stage, I think in 62 or 3 with the Centaur upper stage. No, first the Aegina upper stage. They eventually went to the Centaur upper stage much later on. I don't remember when that was. But yeah, that's kind of how that works. I feel like I'm sitting on top of this guy's head, which is great. What is so difficult to recover the Falcon 9 second phase? Timu, that's a good question. I have a video about that, why SpaceX can't recover an upper stage. I probably need to redo it in Realism Overhaul to really, really give you a sense of how close the margins are. They're just, in order to slow down, so that reentry burn, the faster you're going, the longer and more powerful that reentry burn needs to be. Not necessarily longer and more powerful, but the reentry burn isn't there to slow the vehicle down. It's there mostly just to protect the vehicle through reentry. Now, if your reentry takes 20 minutes to go through, you have to ignite that engine for 20 minutes and survive that long reentry. Either that or you have to make a big, giant upper stage that has aerodynamic forces like wings to help stay on top of the upper atmosphere and bleed off more of that speed for longer. So I think we're at T-minus 4 minutes and 20 seconds.
Go. We're approaching our T-minus 4 minute hold.
And then it'll be a hold.
This is a planned built-in 15-minute hold in 5, 4, 3, 2, 1. T-minus 4 minutes and holding.
So now what they do is at T-minus, so now there'll be a 15-minute hold.
Seconds before liftoff of the United Launch Alliance Atlas V with NOAA's GOES-S spacecraft, the RD-180 engine ignites, supplied with fuel stored inside the large booster. The rocket gets extra power from the 4 solid rocket motors attached to the side at liftoff. In total, the rocket produces 2.25 million pounds of thrust.
Within 35 seconds of liftoff, the Atlas V will be traveling faster than the speed of sound. And within just 4 minutes, the rocket will weigh just a fraction of its original weight after it has jettisoned the solid rocket boosters, payload fairing, and the main Atlas booster. And just over 3.5 hours after liftoff, GOES-S will fly free above Earth.
Here's a detailed look at the full mission profile for today's launch of the Atlas V rocket.
The following profile details the important events of this mission using approximate times.
4, 3, 2, 1. And liftoff.
The Atlas V RD-180 main engine and 4 solid rocket boosters ignite to generate the 2.25 million pounds of thrust.
Actually, no, this is... Okay, so we've already talked about everything in this. I think this is just the GOES-S mission profile. So one of the things that's interesting about ULA is at T-minus 15 minutes, well, technically T-minus 19 minutes, they go into a hold period where they reevaluate everything, make sure everything's good, and then they can actually put in a little bit longer hold if they need to, because their terminal count, like the actual automated count sequence, doesn't start until T-minus 4 minutes. So they could actually kind of hold it. So say weather is looking iffy, they can kind of like be flexible with it, and they have these pre-programmed times where, say they end up saying, okay, let's hold on for 5 more minutes, the upper level winds are too much or whatever. They can hold off for 5 minutes or then wait another 5 minutes or 5 minutes, and then they can commit to launching at just T-minus 4 minutes. This is very different from SpaceX, who, once they start their procedure at about T-minus 50 minutes or so, they're committed to that T-minus 0 because of their super chilled propellants. So SpaceX, with their Falcon 9 now, mostly always have just an instantaneous launch window. So if they start to load up prop and something occurs, a problem occurs, they will have to scrub. And they say, we're done for the day. As opposed to the Atlas V, it can sit on the pad with fuel. And because it's not super chilled and doesn't rely on that super chilled propellant, to get the full performance out of the vehicle, it can sit there in the relatively, you know, with warmish fuel, and it doesn't really matter. They can kind of then go into any of their pre-planned trajectories. And again, this Centaur upper stage that you're seeing on the screen here has basically, they pre-program it for any of the potential hold points and any of the potential times, and then the upper stage basically makes up for the difference. So, well, thank you, Timu. I think we'll have a new computer coming soon, so hopefully it just makes for a better live streaming experience for everybody. And a quicker editing machine so I can get videos out faster too. That's going to be very nice. So yeah, hopefully I answered the question about the upper stage, but I do have a video about it. Again, I need to update it. There's a lot of videos I need to update. That's crazy, CJ. Yeah, staring at the VAB. Yeah, this is a nostalgic launch. This is an old launch vehicle, really. You know, these engines, the RD-180, come from the Soviet Union, and we all know that's not a thing anymore. So it's a different machine. It's a very 20th century rocket, but the thing is, it works. It works really, really, really well. Why, you know, if it ain't broke, don't fix it mentality. So I don't want to talk badly about ULA. I don't want to talk badly about any other launch provider that's doing expendable vehicles, because they all have their own reasons for pursuing what they're pursuing and doing what they do. ULA believes they can bring the cost of manufacturing down a lot in their upcoming Vulcan rocket to stay competitive versus reuse. They just think, you know, if we make our equipment cheaper, make it more common tooling, make it this X, Y, and Z, they hope that therefore will lower the price of their launch costs and be more competitive with, say, the Falcon 9, which is currently about the cheapest thing launching today. So there we go. We see a good, that's where, so the GOES S, what's launching today, is that west one. And the GOES East is what's up there already, launched in November 2016. Anthony, thank you. Will I be doing any live streams for future Rocket Lab launches? Absolutely. Thank you for the tip. Rocket Lab, definitely. I plan to do eventually literally any live stream I can. I feel like I'm also that guy's face right now, which is quite fun. I don't really have a good place to put myself in this live stream, unfortunately. But yeah, I do want to do any launch provider when I can. Again, probably ULA and at least their Atlas V is probably one of the next vehicle I'm most comfortable talking about. Again, a lot of this, you know, I have to just be able to, if it's not up in my head, I can't just freely talk about it. So that's the main reason why I've done SpaceX launches in the past, is because it's kind of my expertise, or what I at least spend the most time reading and researching. And those are the most questions I get, is with the Falcon 9 family. And that's, people ask me a lot, you know, Tim, why, oh, you only do SpaceX stuff? It's kind of a, like a snowballing effect, because I'll make a SpaceX video and I'll get a bunch of new SpaceX questions, and then I'll make a video answering one of those questions, which arises another set of questions. And so I'm not meaning to only cover SpaceX. As a matter of fact, this week's video, that one that I did with Fraser Kane from Universe Today, was an NASA mission. You know, it had nothing to do, I didn't say the word SpaceX once in it. So, and unfortunately, I'm fairly SEO, I'm fairly analytics driven. And for whatever reason, you guys aren't watching the NASA ones. So I don't know what, it's encouraging to me to see growth when I answer SpaceX questions, just because they're a high public company. We tend to get a lot more questions and a lot more engagement. So yeah, I'll continue to do a lot. Like I said, I still have a Rocket Lab video totally planned. I'm going to kind of release that before the next Electron launch, to help answer questions before that, and kind of time it out like that. That's always a good idea. I always think this is sweet. They always like commemorize their rockets to people, which I think is very sweet. Country Farmer, we'll need to talk about that. NASA is not dead at all. NASA, we just have to realize that maybe NASA shouldn't be building rockets. They should be doing this, which is buying rockets from a provider. More instead of, I think the only part that might be dying in NASA's programs are probably them building the Orion and the SLS. I hate saying that, because I have really good friends that work on both of those vehicles. But NASA still is, guys, it's NASA. Who's going to do the science missions? Who's going to run the probes? Who's going to pay for Elon Musk isn't going to send a Titan probe out there to fly around Titan and gather data, and then hire teams of scientists to comb over the data. That's not profitable. And that's still where NASA is in our best interest as the public to be able to learn and still push cutting edge things that might not be profitable. Maybe looking at, new cutting edge, nuclear engines, and looking at plasma engines and more efficient things like that, and literally studying warp drive and if it's feasible, laser communications, all these things. I think that's NASA still, guys, don't discredit NASA. I hate that mentality. It's not NASA versus SpaceX. Yes, SpaceX has come around and they're very fun and very public facing, and they're very, extremely, extremely engaging, and boy, do they make everyone get excited. But they aren't against each other at all. They're very cooperative, and we need to kind of get over that mentality. And even if they weren't, guys, we're here celebrating ULA's launch today. It's all space. It's all for the greater good. We're all in this together. This isn't insert sport team versus insert other sport team. This is us all together. So, and Pablo, thank you for appreciating the hard work. That really means a lot. I try to do my best to stay on top of this stuff. So people look at there. I didn't realize the fairing is cut into quarters then, because that was part of the fairing on that upper stage. It is so weird to me that they attached the fairing that far down on the upper stage. Maybe it's just because here's a theory, I'm making this up, might be right, might be wrong. The Centaur upper stage often looks just like straight tanks. There's no fuselage on it, kind of. It's just a tank in a lightweight structure. So maybe it's easier to protect it aerodynamically with the common fairing and deploy that fairing once it gets out of the atmosphere. That way, you don't have to worry about putting, that way you're not carrying around the skin of the upper stage, the whole burn time of your upper stage. It might actually be really smart and efficient to do it that way. I assume there's probably a reason. I don't know what it is, but there you go. You see, that's the payload fairing, and it's going to be attached. You can see there, it's attached to a fairing that's still attached to the upper stage. So that's really interesting. Should NASA cancel SLS? BFR will be cheaper and can carry slightly heavier payloads. Space Guy asks. It's a very difficult subject to talk about because we're so close to seeing SLS fly. A lot of the engineering is done. I really, really, really still want to see the SLS fly at least once. It's like, you have all this work done, but that's the sunk cost fallacy, because we already have this much work and it would be a shame for it to not fly. At the same time, the sooner we cut it, honestly, it just can't compete. There's already been over $9 billion invested into a vehicle that hasn't flown once. That's insane. As opposed to, something like the Falcon Heavy, which is nearly as capable, only costs up to $150 million. We could have launched a lot of Falcon Heavies for the cost of the first SLS. So my guess is we might see it fly once or twice. I don't think it will survive another administration, though. I think someone's going to look over those numbers and go, yeah, we can probably just hire this out. And that's true. We don't want to cancel SLS until BFR exists, but at the same time, we do now have a heavy lift launch vehicle that works. Sounds good, Faradrim. Thank you for the tip. And yeah, we need to remember, guys, back to the NASA thing. NASA is still where a lot of the research comes from. They're the organization that double checks and makes sure these vehicles are safe for human flight, make sure these vehicles are safe, and double check a lot of the work on the engineering. Everything that NASA does is public domain, so it can be beneficial to all companies. I'm going to go ahead and unmute
Range has conducted its readiness polls. Launch conductor Ed Kitta has asked the NASA spacecraft coordinator to configure NOAA's GOES-S for launch, and launch director Tom Heater has conferred with mission managers for a go, no-go status. We're standing by for a final status check with all launch disciplines.
We're 7 minutes, 13 seconds away from launch. Launch conductor Ed Kitta will conduct a status check to continue the launch count and come out of our T-minus 4-minute hold.
Hey, Charles, great question. You're in the
Status
aerospace.
check to proceed with terminal count. Atlas Systems,
I
propulsion.
want to hear this.
Go.
Back to you.
Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur Systems, propulsion. Go. Pneumatics. Go. LO2. Go. LH2.
Go.
HASGAS.
Go.
Electrical Systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GC cube.
Go.
Com.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline Monitor.
Go.
Quality.
Go.
Op Safety Manager.
Go.
ULA Safety Officer.
Go.
Vehicle System Engineer.
Go.
Anomaly Chief.
AC is go.
Range Coordinator.
Clear to proceed.
Launch Director.
You have permission to launch.
Proceeding with the count.
And as
Failed.
you heard, Launch Conductor Ed Kidda has received a go from all stations to continue the countdown. We're scheduled to release the hold in about 1 minute 45 seconds and countdown to an on-time liftoff of the United Launch Alliance Atlas V rocket and NOAA's GOES-S spacecraft at 5:02 p.m. Eastern Standard Time.
Thanks, Tim Stickles TV.
L minus 5 minutes, 30 seconds.
Start list data capture.
Roger.
Yeah, we're darn close to 100K. so
NSC,
thank you.
verify spacecraft on internal power.
Spacecraft is on internal power.
All steps complete prior to terminal count.
The GOES-S spacecraft configured for launch on internal power. Everything is go. 5 minutes away from launch.
Cool. Hey, Charles, remind me, I'll get back to your question. I do really want to answer that very specifically, especially thank you for the tip. Just remind me, after there's going to be a coast period, I'll make sure and come back, and everyone please remind me, especially Discord, remind me to look
We
at
have
Charles's
45 seconds remaining in this hold.
and address
Plan
that
to
very
come out of the hold and launch at the opening of a 2-hour launch window at 5:02 p.m. Eastern Time.
But Charles, I'll try to answer now if they're not going to talk for a second. I would apply to internships at all of the aerospace companies. There's so many, we have Lockheed Martin, we have Boeing, we have ULA, which is Boeing and Lockheed Martin. We have Northrop Grumman. We have Orbital
NASA
ATK,
Launch
which
Manager Tim Dunn just reporting to Launch Director that NASA is go for launch as well.
Sweet. Apply to them all. Apply to SpaceX. Apply to Virgin Galactic.
On my mark, the time will be T minus 4 minutes and counting.
4, 3, 2, 1.
4-minute countdown now.
And we are at T minus 4 minutes and counting.
After
So
launch,
that's
we'll be
just
hearing
how
the voice
ULA
of
does it.
United Launch Alliance's Marty Malinowski providing a status of the flight of the Atlas V and NOAA's GOES-S.
So now the vehicle's in internal. It's doing its own.
At launch
terminal
minus
countdown.
2 minutes, the Atlas and Centaur power will be internal.
Ground pyros have been enabled. Liquid oxygen securing and liquid oxygen topping are underway.
And yeah, you're seeing the liquid oxygen vent out as it turns into a gas as it heats up.
Atlas
It's pumped
tanks
in as
will
liquid.
be pressurized to flight pressure at T minus 3 minutes.
It's pumped in as a liquid. The ambient air warms it up and expands it as a gas. As oxygen, it goes from a liquid to
Shortly
a gas.
thereafter, the flight termination system will go internal.
It expands 1,000 times, so it needs to vent out instead of rupturing the tanks.
to flight pressure.
It vents out.
Securing LO2 topping.
Man,
250.
Thank you.
FTS internal.
Flight termination system internal. Yeah, so that's why, and then you see that vented oxygen.
Following
and it's
Atlas
still
and
really
Centaur
cold.
power to internal at T minus 2 minutes, the ground launch sequencer will command the launch sequencer to start at T minus 1 minute 55 seconds.
Thanks, Johnny. Thank you, Johnny. So, yeah.
T minus 2 minutes 14 seconds and counting.
The clock's a little behind. This is going to a geostationary orbit, somebody asks.
159,
Vehicle internal.
155,
Launch sequencer start.
And the Atlas and Centaur power is now internal.
Centaur
Yeah, that's-
LH2.
Securing Centaur LO2.
It's Brad. That's a great question. I'll get
The
to
flight
that.
termination system will be armed at T minus 1 minute 37 seconds.
7,
FTS armed.
We are 1 minute, 30 seconds to launch.
So now the main stage
The
here is
environmental
fueled.
control system will be reduced for launch at T-minus 1 minute 15 seconds.
1 minute, 20 seconds.
OCU's armed.
FCS count started.
115.
Reduce ECS for launch.
Roger.
110.
Vent valves locked.
The failure rate
The
of the
vent
Atlas
valves
5
are
is
closed on the
0.
Centaur, liquid oxygen and liquid hydrogen vent.
75
T-minus 1
successful
minute.
launches.
Rock, report range status.
Range green.
Range Operations Controller reports range green. Everything is go. T-minus 51 seconds and counting.
I'll talk about why this launch is significant, or the significance of this launch. It's not highly significant, but it's a cool launch.
T-minus
We'll talk about
40
that here in a
seconds.
second.
Stable at step 3.
Closing in on 30 seconds before launch.
I do love their
3
launch
seconds
tower.
before launch, the powerful RD-180 engine will ignite.
Roger.
25.
Status check.
Go Atlas.
Go Centaur. Go.
Everything is go. T-minus 15 seconds and counting.
Someone was dialing for pizza, or
9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Atlas V and NOAA's GOES, a highly sophisticated weather-watching eye in the sky, to join its twin in providing better forecasts and saving lives.
Atlas has begun a pitch and yaw maneuver to steer to its planned path at an azimuth of 100.7 degrees.
At 35 seconds, the rocket carrying GOES will reach Mach 1, traveling faster than the speed of sound.
it is hauling.
Signatures look good. Roll program is complete.
Go Atlas.
SRB chamber pressures are rolling off as expected.
At 47 seconds after launch, the vehicle will pass through the area of maximum dynamic pressure, or max Q.
That was a cool shot. There we go.
Max Q.
This is the point when mechanical stress on the rocket reaches its peak because of the rocket's velocity and the resistance created by the Earth's atmosphere.
So they'll do the solid rocket
Booster has
will
throttled
separate
up
at
as
like minute
expected.
40, minute 50.
You are also hearing the voice of United Launch Alliance flight commentator Marty Malinowski.
SRB chamber pressures continue to look good at plateaued.
At 1 minute 50 seconds into flight, the first 2 solid rocket boosters will be jettisoned, followed about a second and a half later
Up an SRB
by
burnout.
other boosters.
In the center core,
Yeah, we
of
have
the
indication of
first
SRB
stage
burnout.
will burn for like 4 minutes. So that's a lot longer
Booster engine continues to
than the
perform
Falcon
well.
9, which does like 238, 240, 250.
Approximately 10 seconds to SRB jettison.
So the SRBs they're out of fuel, and they'll be jettisoned here in a second. Notice the exhaust trail
And
looks
we have
very
indication
different.
of 4 solids
there's no
jettison. Looks like a
SRBs.
clean separation.
The SRBs are very dirty.
And a clean
They make
separation being reported
big old
of the
cloud.
solid rocket boosters.
Vehicle
We are
has
2
begun
minutes,
closed
4
loop
seconds into
steering.
flight.
The next major milestone, 3 minutes 30 seconds into flight, the payload fairing protecting GOES during its flight through the atmosphere will be jettisoned 3.5 minutes after launch.
Cool. So yeah, and they deploy the fairing while the first stage is still burning. That's something, again,
Booster
very
has
different.
throttled down as expected. Up on the RCS pyro valve activation.
I want the rocket camera. I don't like these boring cameras.
We have the RCS pyro valve activation at this point. System is pressurizing to flight levels. Signatures look good.
Yes, it is pollution. These rockets do pollute,
3 minutes into the flight.
but compared to like the rest of the transportation industry, it's very, very, very,
Booster
very,
has
very little.
throttled back to 2.5 Gs. Preparation for payload for jettison.
Okay, let's find a better place for me to put my face. Maybe down here. So you guys can see those numbers.
10 seconds away from payload fairing jettison.
So we're just over 100 kilometers in
Payload
altitude
for
right now.
jettison momentarily. We have good payload fringe separation and CFLR jettison.
See, isn't that weird?
And we have a good payload fairing jettison, exposing GOES S to space for the first time.
Jettison the fairings while the first stage is still burning. Just interesting. Makes sense. Get rid of them as early as possible. They're just dead weight once you're out of the atmosphere.
We are approaching 4 minutes into flight.
And booster has begun to throttle to 4.6 Gs in preparation for pico. Boost phase cooldown is underway. Local pyro valve has been fired.
The call BECO stands for Booster Engine Cutoff. That will happen at 4 minutes 22 seconds into flight.
Boost phase chill down is complete. And we have pico. Shutdown looks good.
6 seconds after BECO, the Centaur second engine, or second stage will separate from the Atlas booster.
The RL-10 engine.
Here we go.
GN2 purge firing. The RCS is underway. We
Here's
have
a rocket
ignition
cam.
and full thrust on the RL-10.
And the Centaur single engine RL-10C engine ignites for the first time. It produces 22,900 pounds of thrust.
It's an awesome engine. It's very expensive, but it's awesome. Very efficient. Crazy efficient.
Our steering has been enabled. Fire rates look good.
This is about a 7.5 minute burn of the Centaur RL-10C engine.
Fixed angle, as expected.
Engine cutoff planned for about 7 minutes from now.
It's a long burn, and it's one of 3. So they'll have a long coast period.
This is the first of 3 burns of the Centaur main engine.
Continue to warm towards bottle temperatures. Signatures look good.
The tube on the right is the turbo pumps exhaust. It's not regenerative cooling.
Loop control.
So that's exhaust from the
Current
turbo
range
pump.
track shows Centaur making good headway down the middle of the corridor. Current altitude is 129 miles. Downrange distance is 701 miles. Current velocity 13,903 miles per hour.
Listening to the voice of United Launch Alliance flight commentator Marty Malinowski, describing the flight of the Atlas and Centaur.
Shows basically a nominal booster.
All right.
Beginning to see the RCS thermal conditioning firing. Signatures look good. RL-10 continues to perform well. Chamber pressures, lax pump discharge, and fuel venturi, all appropriate for the mark.
So also, ULA chooses to use the animations when the rocket goes out of range of cameras. You can still see it on the cameras. That's why you get we start getting those blurry, crappy little 10-pixel images because the vehicle's hundreds of miles downrange and 100 miles in altitude. So it doesn't make for exciting footage. That's why ULA chooses to go with those other the animations until they get to this upper stage camera. But meanwhile, this upper stage is packed inside a fairing, so you don't get any footage from it while it's in that fairing. And so they don't do it until
we're 7 minutes into the flight of GOES S. Another 5 minutes remaining in this first burn of the Centaur single engine.
It's also stuffed
As
inside.
resumed, all signatures look good across the dropout.
It's also stuffed inside that inner stage as well. So it's stuffed inside 2 things. Isn't very compelling footage normally. You also might lose ground tracking satellites to relay that video feeds. They might bounce back and forth between the 2. No big deal. No conspiracy theory. Just how it works. I'd rather be looking at this.
146 miles. Downrange distance 1094.
And I want to see this. These
Velocity
are the
is
numbers
14,685.
that I like to see. Sorry, my mic is... I'll turn myself up a little bit here. Hopefully that'll help you guys. I may have been a little bit conservatively quiet here.
8 minutes after liftoff, and everything continues to go well.
Okay, so one of the things we need to talk about is what's interesting about the Atlas, especially any Atlas with a solid rocket booster, basically has 3 different types of fuels.
We have about 4 more minutes left in the burn of the Centaur main engine cuts off.
We're just going to do this because unless something happens. So basically has three different types of fuels. There's solid fuel on those solid rocket boosters. There is kerosene, which is RP1, which is the same type. That's a very common rocket fuel on the first stage. That's also the same fuel that SpaceX uses on their Falcon 9 and Falcon Heavy. It's RP1. It's highly refined kerosene, basically jet fuel, but even more refined. But then their upper stage uses liquid hydrogen, just like the space shuttle with that big orange tank used liquid hydrogen and liquid oxygen as its propellant. And it's very efficient. It makes for a great upper stage, actually. There's a lot more potential for a higher specific impulse using liquid hydrogen in general. But it's interesting that they have to carry then on the launch site, they have to have the two different liquid fuels and liquid oxidizer. And then obviously like the solid rocket boosters use a totally different fuel, if you will, different propellant at least, we call it. Fuel can be misleading because it's, infers liquid kind of. So the propellant on those solid rocket boosters obviously is basically just like rubber, which is weird. But people were asking about the pollution of them. Yes, you see those solid rocket boosters do kick out a lot of carbon, and you see it look like clouds. It is pollution. The rockets do pollute. It's kind of one of those things you just have to deal with, and Elon, people go like, how dare him launch polluting rockets when he's trying to make all cars things. The amount of total carbon output of all rockets is so negligible. There's so much bigger fish to fry, and unfortunately, if we want to do things like have weather satellites, if we want to launch people into space, if we want to continue to advance our communications network and defense systems, there is no other way to get into space. So if you're talking about maybe we shouldn't be doing that when we're talking about like 0.1% or something, I don't know the numbers, and actually I plan to do an in-depth video talking about the actual carbon output of rockets versus the rest of the transportation industry. And I'm sure it will be a very small percentage compared to even like the shipping industry and the semis and all that stuff. So yeah, so there we go. That's the hybrid engine. They burn aluminum. Interesting. But it's in this like rubbery compound. So use aluminum, not rubber. There we go. Let's see. Let the engine burn out. Count 2 seconds, then do a stage separation. Yeah, hopefully that helps. Let's see here. Use all hydrogen like the Delta 4. Can I scoot so you can see the map? Yes, I can. People are cheering. I'll do this. I'll just be bouncing around the screen wherever you guys will have me. So I will definitely be doing a video, an in-depth video talking more specifically about the carbon output of rockets, because it is an interesting topic. So why can't they use hydrogen for all stages? Randy asks. They could. Just different designs, different parameters. I don't know. I don't know why exactly they don't do that now. But we do have for instance, the Delta 4 is a hydrogen-based vehicle, and it uses that I can't remember. It's not the RL-10. That's what this is. I can't remember which. I think it is an RL something though. RL Stein, but it is also a hydrolox engine. But there's different reasons for different things. If this is the cheapest option and it gets it done, then apparently they have that, but they also have the option to do all hydrogen, and they have, it's weird. It is weird. You'd think you'd kind of optimize one vehicle, but ULA kind of has, currently they still have 3 vehicles, the Delta 2, they have the Atlas 5 here. There we go. There's the main engine cutoff, or SECO really, second engine cutoff, because this is the simulation of the actual, Timu, good question. Thanks for the tip. This is a simulation of the actual what's going on. They just, we don't have ground tracking cameras. Occasionally they might track over to the camera on the upper stage, but ULA tends to not do that. They tend to just do the animation aspect. So RS-68 modified KS-25. There we go, James. Thank you. Yeah, they call it main engine cutoff because it's ULA. They tend to do that. Yeah, see, there we go. Even up at the top of the screen, it says MECO, because they are talking about the main engine of, even though there is only one engine, of the upper stage. So they still consider it MECO, which is interesting. Yeah, why didn't they talk about the actual main engine cutoff of the RD-180? They have launched. The next event was MECO 1. There's going to be a 3-hour coast period, guys. I don't think I'm going to stream during that, But hopefully we can answer some questions in the meantime. Why do they use miles and not the metric system? That's a great question. ULA still mixes and matches. They do some things such as the 5-meter fairing, and not all. Yeah, it's interesting. SpaceX from day one decided that they would not allow English or Imperial system anywhere on their factory floor in their engineering. From the ground up, they went with metric, which obviously is the right choice. ULA still is kind of mixing and matching. Maybe they think they're catering to a U.S. audience, therefore they need to be Imperial. I'm not entirely sure. So there we go. That's why. Oh yeah, It's Brad had an interesting question. I wanted to talk about that. Hopefully I got it. Oh yeah, he asked. It's Brad asked why don't they just wait a few seconds to jettison the side, or why do they wait a few seconds to jettison the side boosters? Isn't it just dead weight? Yes, it is, but it can be even residual thrust for a little while, and I'm sure they just have it timed out that as soon as they know, the burnt SRBs are no longer even having any exhaust, just like, for instance, Falcon 1 Flight 3, the third launch of SpaceX's first rocket, the Falcon 1, they made a small tweak to the Merlin engine, a lot of tweaks, and it ended up being the Merlin 1C engine as opposed to their Merlin 1A. And what they didn't account for is the fact that after ignition, or after they cut off the engine, the main engine, there's still a little puff that was negligible on a launch. When it was down here at sea level, they didn't measure any extra thrust. The problem is, once it was in the vacuum, that little bit of thrust was actually a pretty big issue. And so after they did stage separation, after the upper stage separated from the first stage, it ended up ramming back into the upper stage because there's still a little bit of thrust being produced by that first stage. And even though it let go of the second stage, it ended up just catching back up and ramming into it, which is not a good thing, obviously. So that being said, it's lessons like that learned that maybe, we make sure these SRBs are totally burnt out before we jettison them. And yes, the sooner you jettison them, the sooner you can make up for it. They're just dead weight, so you want to get rid of them as soon as possible. But you also want to be safe about it. So it's probably just that whole bit there. So, yeah. I also don't think they carry Arco thinks that they carry the SRBs along so they splash down far enough away from the ocean. I don't think that's true. That whole, as long as they're, that whole, oh, excuse me. Sorry. They're in an exclusion zone the whole way, so they really can jettison those anywhere. And it doesn't matter where they crash in the ocean. Yeah, there we go. Let's see. Sorry. Yeah, SRBs are great. Thanks, everybody. SRBs are great for initial launch because they have a very high thrust-to-weight ratio, but they aren't as efficient in like a vacuum. So they're great they're inexpensive, so they make for great, you strap those babies on, you get an additional whopping bit of thrust, and you can either throttle down your main engine and let it burn longer, or if it is such a heavy payload, you might just need to have those to basically get off the ground. You also counter gravity loss. So the more thrust to weight ratio your entire vehicle is, the less you're fighting gravity. So pretend you're, for instance, say you're a rocket and you just took off the pad, but you're just sitting there hovering. You're just sitting there wasting fuel. You're fighting gravity. If you're hovering, you're at a 1-to-1 thrust to weight ratio. The amount of thrust the rocket's pushing down is the same as gravity's trying to pull it back. Anything above that, say you're like 10% above that, you're 1.1-to-1 thrust to weight ratio. That's really inefficient because 90% of your fuel, 90% of your energy is just fighting gravity. Only 10% of that is actually going in the direction, getting you gaining velocity, and you really need to gain a lot of velocity. So if you say you get that up to 2-to-1, a 2-to-1 thrust to weight ratio, that means you're double as efficient, or actually you're infinitely more efficient than hovering. But say you go from 2-to-1 to 3-to-1, you're twice as efficient as 2-to-1. So it does make sense to have a lot of thrust on that first stage to really just, counter all that gravity loss as much as possible without pulling too many Gs. Rockets tend to not go over 4 or 5 G's of acceleration because it takes takes a strain on the satellites, the payload, the fuselage, all that stuff. But it is also advantageous to have a lot of thrust to weight ratio. Yeah. If Blue Origin does another launch after New Armstrong, will it be the new Young? Good question, Footy Nut Guy. If they were to do something after New Armstrong, I don't know what their next nomenclature might be. It might be, Young and Crippen, but that's almost as, I don't know. I have no idea maybe they'll do a new Bezos, because maybe they'll consider that like the next step. And I don't know. I don't know what the naming scheme will be. Did I see the 3D audio recording of Falcon Heavy on YouTube? And have I looked at Reaction Engines Limited are trying to develop? I don't think I am familiar with the Reactions Engines Limited are trying to develop, Matthew. But I did see the cool audio that Smarter Every Day did. That was pretty awesome. Listen to that. My dad has a nice home theater system, and we gave it a good listen to there. That was awesome. No, it's not. The New Glenn is what's after New Shepard. After New Glenn is New Armstrong. So if Blue Origin does a new rocket after New Armstrong, it won't be called New Glenn because that's already their upcoming rocket. The next rocket would be something beyond landing on the moon. I want to hear this because we're probably about to get into second engine reignition again. This is what will, I think, kick it out into its a little bit raised apogee and then a long coast period. It's so weird. And then they do like an inclination change and a perigee raise too at that next burn. Oh, the Sabre engine. That's what reaction engines. Thank you. Yeah, the Sabre engines is really cool. It's been around for a long time. They've been working on it for a long time. They did get the pre-cooler thing figured out, I think, which is how do you take air and turn it into basically you have to like flash freeze it when you're going that quickly. All this weird stuff they have to figure out how to make an air breathing engine also turn into a rocket engine. It's an awesome concept. I love it, but really at this point, unless they get some serious funding, it's not going anywhere. And quite frankly, guys, traditional rockets work great. I know it's cool to have like a SSTO style air breathing engine, and it makes sense, pull oxygen from the air, but there's a lot of challenges that come along with that, a lot.
And Centaur has gone to 100% for us settling in preparation for S2. Tank pressures are being increased as well.
That's it. Hey, Dorkmata Gaming, that's a good question about controlling SRBs. I didn't realize
1
that.
minute before the Centaur second stage ignites again.
Thank you, S. Young.
GOES will eventually be in a geosynchronous orbit, which is an orbit that keeps the satellite over a specific location on Earth. By maintaining a hovering position over a fixed point on Earth's surface, GOES are able to constantly monitor atmospheric conditions in a particular portion of Earth's atmosphere.
"30 seconds away from the Centaur second stage engine restart."
So someone asked,
again, this is a burn known as MES2, main engine start 2, for the Centaur main engine.
So these are Ullage motors?
We'll hear the call from Marty Malinowski.
Accelerating so the fuel and propellant gets pushed back into the bottom of the vehicle so that they can get sucked up by the pumps as opposed to just free floating in zero gravity environment.
We have ignition and full thrust on the Arrow-10. This burn is currently scheduled for a duration of 350.5 seconds.
And as you heard, we have a good main engine start, 2.
Has been enabled and currently commanding in oxidizer-rich condition. Chamber pressures, box pump discharge, and fuel venturi all look good.
This burn will last about 5 more minutes.
Hydrazine lines are at bottle temperatures at this point. pressures are good, storage bottles and batteries are as well.
So yes, and now the ULA motors, those little thrusters don't need to fire. The main engine is providing ample, beyond ample acceleration to keep that fuel pushed back kind of at the bottom of the tanks. Think about if fuel was just floating freely like this and you had a tank, you know, and you had to catch it.
112 miles, downrange distance.
Scoop it up.
5,470 miles. Current velocity,
Push it all to the back.
18,544 miles per hour.
So that's what those little ULA motors do before they reignite the engine. And that's once the engine's burning, it obviously has ample acceleration to do that. So you see that SpaceX also does that with little nitrogen thrusters after separation before they ignite their Merlin 1D vacuum engine. Can I move the... Yep, I'll just keep dancing around here. We'll go up here because there's nothing up there very exciting. Now you get to see that beautiful engine animation. Why do they use 2 burns to raise the apoapsis? That's a great question. This one, I think what they do mostly, this seems to be more than a geostationary transfer because they actually raise the periapsis at the next burn. But it's not quite all the way out there at geostationary. It's not at that 22,000 mile altitude. So it's also, I think, an inclination burn. I think they kind of mix it in. And so therefore, I think the satellite ends up having to do a little bit less work than it would on a typical geostationary orbit transfer orbit, but I'm not entirely sure. I think this for sure gets them. I think they were in a parking orbit before, and now this will be putting them into a raised apoapsis or raised apogee. Yeah, so you can see the apogee increase here. There we go. Good call, somebody. Thank you for pointing that out. So the lowest point in their orbit is about around 100 miles. And then their highest point is about 3,000 right now. So the further they burn, they're at the lowest point right now, basically. The longer they burn, the higher up that that apogee, the apoapsis, will go. Winiards asks, is SpaceX only trying to recover half of the fairing for now? Yeah, for now, I think they're just focusing on one, so they aren't wasting the effort trying to catch 2 if both are going to fail. I think once they figure out for sure how to catch 1, then they'll worry about recovering both halves. I think that's right. Faradrim, let me check your question. I kind of wish you would have re-asked it so I don't have to try to find it in here. Man, I'm checking Faradrim. Thank you for the tip, but this might be way up here. I don't see it. If anyone catches it, let me know what their question was about asteroid mining, because I am not seeing it right now. With the Starlink system under development, showing that SpaceX are branching out, do you think that they'll start asteroid mining? Okay, there we go. Thank you. I don't know. I don't think SpaceX wants to get into asteroid mining per se, but they can clearly provide the launch service to do so. So there's companies, that are looking into mining asteroids. That's what they want to do. And so I don't think SpaceX per se, that's not part of their business case, I don't think. I think their business case is to get those customers up into space. Let them do the asteroid mining. But then again, they are doing their own internet constellation, and they could easily have just done that for someone else. So I don't know, to be honest. I've never heard them mention asteroid mining once, if that means anything. Let's see. Just trying to catch up here. Is asteroid mining actually viable for getting resources down here to Earth? Maybe that will be a business case. Is it worth going and getting rare earth mineral, elements, things that we barely have here on Earth, like platinum and things like that? Is it worth going up to space to get? And if you can bring back thousands of pounds or tons of, of or thousands of kilograms of platinum, can you offset the cost of launch and actually make a profit off that, a healthy profit? Who knows? People are crunching that number all the time. So now, by the way, the stage is coasted. It's done with that second cutoff of the upper stage. Now they raise the apogee. You can see it's pretty high up there. Let's see what they have to say here quick. I'm just going to tune in for a second.
The GOES-R series features important technology upgrades and advancements. Blair Allen from NASA Edge is on set with NOAA's Jim Yo, Chief Administrative Officer for the Joint Center for Satellite Data Assimilation. Blair?
Thanks so much, Tori. Jim, first thing I got to ask you is, tell me, what do you think of the launch?
Well, this is my first launch live. It was really exciting, I got to say.
Maybe it's my computer.
But I'll tell you the truth.
Let me just double check.
Exciting, I got to say. But I'll tell you the truth. I'm even more excited about the work that's coming up for me and my colleagues, putting these new data to work for better forecast and warnings for the American public.
Well, you know, it's interesting because John Leslie, who works for NOAA, told us you were the weather satellite expert. So I imagine from your perspective, with all these new advancements, you have to be very excited about the things that you're going to be able to do now that when GOES-S becomes operational.
Absolutely. And of course, we started seeing some of the promise of this from GOES-R. You know, we saw the benefits that we were hoping we would get from having the advancements from the advanced baseline imager with more channels, allowing it to differentiate more features in the atmosphere and on the ocean and land surface, from having better resolution that could help us, you know, see the fine structure of storms and wildfires and any number of things like that, and finally having the rapid scanning that, you know, 5 times as often as the previous generation of GOES that help us see the evolution of storms and give more timely warnings.
Well, okay, now speaking of that, just give us a sense. I mean, I know it's fast, but how fast are we talking when you think about being able to see something happening in the data on the satellite when it's really happening on the ground?
Right, it's almost instantaneous. In fact, this is really for near real-time warnings and information being passed to the public and to decision makers. We're actually able...
So I'd rather answer questions. So back to the asteroid mining thing too quick. The other potential for asteroid mining is using elements up in space and keeping them in space and then selling them off as rocket fuel and other things to other space companies. So that's obviously an option. You know, there's a lot of value in, you know, water in space is worth a lot. Think about how much it costs to launch a kilogram of water here on Earth. Obviously, if you can pull, it might be a business case to pull water from other places, use electrolysis and separate it into hydrogen and oxygen, or just oxygen, or just use it as potable water for drinking, or whatever you need to do. Yeah, it's an interesting case, and there's literally dozens of companies starting up that are studying the viability, especially as the launch cost comes down. The potential for asteroid mining goes up and up and up and up, because obviously, if you have a $500 million launch cost to get out to an asteroid, that's very cost prohibitive. But if you get that down to $50 million, you might open up some new doors. So, Iraqi atheists, let's make NASA great again. Elon actually would strongly disagree. Elon's a huge fan of NASA. He said that multiple times. SpaceX would not exist without NASA. NASA's been the biggest funder of SpaceX. NASA has provided billions of dollars, 1.3 I think so far to date, to help develop not only the Dragon capsule but also the Falcon 9. And Elon, as a matter of fact, he even shared that one point his password on his computer was "I love NASA." They aren't these competitive forces, you know. So, yeah, let's try to remember as a space community, guys. I don't like the negativity, especially aimed at NASA. NASA's incredible. None of this would be possible without NASA. We need to remember that. And yes, they have some inefficiencies, but at the same time, they have things that they can do that no other organization, no private company can do. And I'm going to be talking about that a lot in an upcoming video. So since I'm going to end my coverage of this launch here because it is getting long. We've been long-winded. I'm going to answer any more questions you guys have. Comet mining, same type of thing. Yeah, comet mining has a lot more potential for liquids than standard asteroid for the most part, because comets oftentimes have like ice trails. You know, ice gets melted off and all that stuff. But I don't know a lot about that. I'm sure people are researching that exact thing, and they're probably figuring out exactly what makes the most sense to go mine. Yeah. let's see. Well, thank you. I got to figure out how to say your name, Van Noonen. The 404 meter, yep. 5 series, yep. Let's see here. Why don't I play KSP right now? Because I had enough people already complaining about the amount of Kerbal I've been playing lately. Even though I did a little bit on Sunday because it was a day off. I streamed a little bit of Kerbal for my birthday because it was my birthday. And then I did our show that we do today-ish in spaceflight history with Jacob EQ, where he asks questions. I did realize last night we didn't have a very thick topic. It wasn't, if you watch last night's replay of today-ish in spaceflight history, I didn't know, there wasn't a lot of information about this rocket glider. I just thought it'd be kind of fun. I realized I think I had to focus more on missions that have a lot of depth to it. I'll make sure and read up on it and talk about a lot of that stuff and make sure Jacob's able to ask a lot of questions. There weren't a lot of questions for him to ask last night because I didn't know all the answers at all. I didn't know the whole story. There just wasn't much to tell there. So hopefully in the future, Jacob will be able to ask better questions. I'll be able to tell you more of a fun story and hopefully learn a lot more out of the today-ish in spaceflight history. I'm listening to your feedback. If you guys think that I'm doing too much, if we're dinking around with music too much and things like that, I'm listening to that, and I'll definitely provide the feedback and continue to make the show better, because it's for you guys. It's not for me. So if you get something out of it, that's what it's for. Let's see here. I definitely think the fairing looks cooler with the bigger fairing. So the next video, Josh, I think I officially decided. Hey, Philip James, actually, yes, I did see your email. Let me just tell you this now. Look back at some of my old live streams. I did exactly what you wanted me to do. And it is kind of funny to have to juggle around my face in live streams like I'm doing now. But I tried it the other way, and a lot of people were complaining that there's a lot of dead space, and they said, just do what Scott Manley does, which is just the picture-in-picture thing. It kind of makes sense to me, too. Unfortunately, when you shrink the two, it just ends up being... It's a compromise either way. This one looks simpler, and I decided the branding might date itself, so I just tend to keep it as is. And again, that's one of those things that I had a lot of feedback on. So just kind of listening to you guys. The other question was, let's see here. My next video, I decided today, officially, I said, if you want to find my email, go to everydayastronaut.com. You can find where to reach me there. I did decide today that I think the next video I'm going to cover actually is Block 5 of Falcon 9, which you can see is right there compared to the Block 1, 2, 3, or 4, whatever. I'm actually still trying to get the bottom of Block 5 because I've always considered it. The first flight of Block 3 was version 1.2 of the Falcon 9. And now I'm seeing some contradicting info, and I've heard people have this debate. I'm going to try to settle the debate. I'm trying to get to the answers. I'm reaching out to some resources, to some sources to really try to figure out, is the block scheme different from the full thrust, fuller thrust, the 1.0, 1.2, 1.3, whatever, blah, blah, blah. I'm trying to get to the bottom of it. The video will take a little bit more back-end research on my end and really trying to figure out the real root of Block 5. But then, importantly, we're going to talk about what's new in Block 5 for the Falcon 9, why it's doing that. I'm doing that so we can compare the Atlas V that we saw launched today to the Falcon 9, because that will be the video that follows that. The reason that I want to be able to define Block 5 is Block 5 is what's going to be carrying astronauts to the International Space Station, while the Atlas V is the other vehicle carrying astronauts to the International Space Station as early as the end of the year. And so I don't want to talk about the Block 5 Falcon 9 if we haven't defined and gone through the specs of the Block 5 previously on the channel. So we'll start off with what Block 5 is, how it got there, blah, blah, blah. And I'll really define what that is, hopefully. Like I said, I hope to get to the bottom of it. And then what we'll do after that is, and then after that we will end up doing a comparison. Yeah, the Atlas V in I think it's the 402 configuration. I have to remember if that was just for the Dream Chaser. But I'm trying to remember if Starliners is also going to have a 402. Which would be weird because it hasn't flown in a long time. So it'd be weird that they're first. I don't know. We'll have to figure that out. We have a lot of work to do. So, yeah. Let's see. There we go. Blah, I think, is being critical of the fact that I don't talk about ULA during SpaceX launches, but I discuss SpaceX during ULA launches. we talked about ULA for about 50 minutes straight, and we have questions about SpaceX. I'm here to answer questions. If people ask ULA questions during SpaceX launches, of course I'll answer them. I'm just giving the people what they want. If you don't like that, you can tune in to ULA's official launch. Hopefully they'll answer the questions you need. But I think we covered pretty much everything we need to talk about with the Atlas V today. I'm watching some kind of cool replay footage right now. Maybe we should have this pulled up. They go into like graphics and then replay. The O, Josh Kaufman wants to know what the O is in the 402 configuration. That'd be 0 solid rocket boosters. Will Russell, I'm good. How are you? I am going to be going right. So launch already happened, Nick Potts. The launch happened about an hour and 30 minutes ago. Or was it? No, 30 minutes ago, 35 minutes ago. It's actually still going on. There's a 3-hour coast phase right now. I'm not going to live stream that long. I'm actually going to tune out here soon so that I can get into scripting. And then somebody else, will I be on tomorrow this Saturday? No, I will not. ULA stands for United Launch Alliance. Let's see. Yeah. SpaceX does things faster than ULA. So there's, yeah, Philip James, that's exactly right. People want to know why SpaceX all the time. Keeping up with SpaceX is like a full-time job, and I'm dead serious. I can't produce videos fast enough to answer your guys' questions about SpaceX. That's why ULA has been in a design freeze with the Atlas V for a decade. You know, what's new and exciting to talk about? The Vulcan rocket has been on the table for 3 or 4 years, and it won't be flying for another 3 years. I mean, that's just the reality of the situation. I will gladly talk about any space news, but you tell me a company that's making as much space news as SpaceX. And the reason they're doing that is they are at ludicrous speed. You know, they are just doing things at this is akin to the 60s when we are going from, holy cow, we made the Atlas vehicle, we put someone in orbit, now we're going to try out the Titan vehicle, and then we're going to kind of do this, now we're going to build a Saturn 1B instead of a small Saturn 5, blah, 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 and then we're going to do Saturn 5, and it's going to all happen within a decade. That's the same foaming at the mouth pace that SpaceX is on, and it's really exciting, and there's a ton of questions behind it. So that's why. That's the truth of it. And as soon as another company comes along and can keep up with that pace of changes, that's, yeah, it's busy. Yeah. There we go. That's true no matter what. Yeah, very minor changes to the Atlas V, things that we don't even hear about, like, we made it so this valve, the stiction on the valve is 1% less due to an upgraded lubricant. And as you know, that, you know, it's just, we don't hear about it. So, yeah. What other rocket from another company could have delivered this payload today? Asked Pierre. That's a great question. You know, I think the Ariane 5 would have been capable of it. I believe the Falcon 9 fully expendable could have taken care of it. And also the Falcon Heavy fully reusable could have taken care of it easily. Yeah. Let's see. Andrew Winter, will the first Block 5 Falcon 9 launch try to land back at LT1? I don't actually know. I don't know the weight of the payload. I don't actually know where that Bandung sat is going or what it's doing. So I don't know for sure. I'm sure we'll find out really soon. Yeah. NASA, I'm sorry. NASA launch streams, I'm sorry it won't let you join Patreon. Sorry. Hopefully you can get it figured out. But thank you for attempting to. You're right, Blah. ULA is developing the smart system, the smart upper stage. But that's, again, not slated to fly until at least 2022. That's a long ways away, and it'll take a long ways for that system to kick in. It's a great system. I totally agree. The smart reuse system is awesome. It's a way to reuse the upper stages by docking them together and refueling, but it has to, you know, keep pressure in those stages so it doesn't all vent out. Look at how quickly, you guys aren't seeing that, sorry. Yeah, it's a cool system, but again, yes, we've known about the smart system for 3 years now, and we're still more than 3 years away from seeing it even be really put on the table. So again, I'll gladly talk about smart reuse when it comes up. I want to talk about smart reuse, but give me something to talk about, you know, make it happen, get it out there. And then I'll talk about it. That's all there is to it. Yeah. Oh, sorry. That is ACE's upper stage. You're right. That's the advanced cryogenic upper stage. Sorry. Smart reuse is the engine detachment. I talked about that earlier in the live stream. You're right. The smart reuse isn't slated until like 2024. So again, now we have to wait 6 years. And again, it's when they detach the main engines of the first stage. There would be an inflatable heat shield that allows it to re-enter through the atmosphere so it doesn't tear it apart. And then it would release a parafoil and get swooped up by a helicopter. That's the reuse plans. Again, that would be disposing of the primary booster or the actual fuselage. Sorry, I forgot about that, guys. Yeah. So it's smart. The smart system is cool. I would love. Why don't they do that now? That's the big question. Is if you see it as being smart, if it's a smart thing to do, if it's economical, do it now. Get on it. You're wasting time and money by not getting on systems that can lower the price. That's my personal opinion. I think that's one of those things that's been so encouraging and so different about SpaceX's approach is that they say, hey, I think this will work. Let's try it. And if it does work, we'll keep pursuing it. If it doesn't work, we'll learn from it. It's just that's not traditional. And ULA is a very traditional aerospace entity. They do things the way it's been done because it works. And that's why they have 100% success rate of the Atlas V. That's why they have such a long lineage of reliability. I totally get it. Totally get it. But it's also why we don't see rapid evolution. So there we go. Let's see. Let's see here. Yeah, if people are asking about the next launch would probably be the Hipposat launch, which we don't actually know the date on yet. So there we go. Since SpaceX don't defend their patents, what prevents other rocket companies from using their designs, or at least moving forward in their direction? Well, Josh Kaufman, that's a great idea. I don't think SpaceX even files for patents. I don't know actually how this works, but I think you'd have a hard time figuring out a lot of their internal things. I don't think they'd file a patent for something that's totally in-house and unknown. They can keep it secret under ITAR and under just NDAs, non-disclosure agreements, things like that. There's things that just aren't public-facing enough for them to worry about being copied and replicated. Other things are like Tesla. They release into public domain. They let people have their charging patents and things like that. But that's different. I don't know. Does anyone know how that works? Let's see. It did already launch. Yep. Yeah, there we go. It's trade secret type stuff. There we go. There we go. Yep. Has anyone seen the Humanity Star yet? That's a good question. So for those of you that don't know, the Humanity Star is a secret payload that launched on that Electron, still a test launch that happened, when was that? In January sometime. They put basically a disco ball in space that will be visible for most of us here on Earth at different points, depending on, where it's the inclination and the light hitting it and things like that. Hopefully visible throughout the next 9 months or so. I don't know if anyone's actually been able to see it yet. So, will I Toby wants to know if I'll live stream ESA launches. Maybe eventually I'll live stream some ESA launches, especially big ones. I need to. Again, guys, I'm just kind of doing the ones that I'm comfortable talking about. I don't want to get outside of, not my expertise, because I don't really even have an expertise, but I don't want to get outside of even just comfort zone of being able to casually talk about things. I know almost nothing about the Ariane 5, and that's the most common launch vehicle that would launch with ESA most often. So, Jaylene Nathan, what happened to Zuma? Check out, I have a video titled exactly that, basically. Check that out. That'll answer your question very bluntly. So why does SpaceX keep trying to launch Hipposat a bit past midnight? Average Joe asks. There's, depending on where the satellite's going, depending on what orbit, for any launch provider, they have a launch window. And so, especially when rendezvousing, this won't be rendezvousing with the International Space Station, but when doing other things like that, there's always going to be a time when the Earth is aligned with the particular orbit and things like that. This is apparently where it lines up with its destination, is just around midnight. So, yeah. Let's see. Sam wants to know if we learned anything else about Zuma. No, we haven't. I don't think we will. Like I said, it's not some conspiracy, but it's a top secret payload. I really don't think anything bad happened. Otherwise, I think there'd be some. Yeah, we'll put it this way. SpaceX said everything went fine. Northrop Grumman can't comment on the matter, and the only sources we have are from 2 anonymous sources citing that something went wrong. Yeah, everyone else, who knows? NASA looked into it, said that they see no reason to review further. That's all we know. That's all we need to know. That's a good idea, Joel Plant. A video about launch windows. I like that. Yeah, so there we go. Let's see. Sorry, people trying to catch up here on the Discord channel. There we go. The launch already happened. The game 953, you'll have to watch the replay. It's in a coast phase right now for about the next 2.5 hours. Yeah, I think, guys, I think that's going to be it for me because, do I have an Instagram? Instagram, boom, maybe. Of course I have an Instagram. That's where this all started. Everyday Astronaut. If you want to know what Everyday Astronaut is, why it started, how it started, make sure and check out my video, How a Spacesuit Almost Killed Me 3 Times. That's a talk that I did. It's kind of like a TED Talk at this conference down in Florida. You'll learn all the backstory of Everyday Astronaut. You'll learn how it all started on Instagram and pictures on Reddit and how it turned into this. Yeah, there you go. There we go. That's the Instagram thing. I don't know how to do that apparently. Saybot, where can you get the rockets in the background? Link in description. Also, we can do, there's like a thing, Nightbot thing. I think that's going to do it for me, guys, because I got to start working on scripting this next video. I don't try to do a video a week. I want to do a video every week, but my theory is I'd rather just get the video done when they're done. I don't want to push and not get the facts right. I don't want to put these crazy hard deadlines on myself that make me not sleep and lose mental health. I have a lot of cool and exciting things coming up, I promise. I have a list literally like 30 things long of videos I need to do. So I know I have plenty to answer for you guys, and I can't wait to get to those. And I hopefully actually will be hiring an editor soon so I can edit and shoot and keep up on stuff even quicker and easily be able to do a video a week or more. But for now, I'm just trying to get them done when I get the research done, when I get the shooting done, when I get the video done. So they'll be out as soon as possible. Meanwhile, check out my old videos, guys. I have a pretty big catalog now of probably 15 to 20 of the scripted research videos. Don't watch the oldest ones. There's like the first 3 are pretty embarrassing, and I really want to remake them. I especially want to redo like the why they don't use parachutes thing, because a lot of that stuff is wrong, and I could combine that with the how SpaceX lands the Falcon 9. I think I can combine those two into a better research video now. Yeah, so stay tuned. There's a ton to come, way too much to come. We have a lot, so we're getting close to 100,000. Hopefully that'll happen sometime in the next couple weeks or something. Yeah, you're right. I will be buying a new computer, and I'm also going to hire an editor. That's so that we can both work side by side. And I'm hopefully going to get a studio space going soon. And then I'll have office space to have the 2 of us working side by side and able to edit in real time. And I'll be able to use 2 computers to render quicker and things like that. It'll be a whole slick setup. So, yeah. Yeah. Electron rocket, remember, like I said, we have that all scripted out. It's 8 pages long. It's really in-depth video all about the Electron and Rocket Lab. I'm waiting on that one to shoot it until we get closer to the Electron launch, in case we learn the next Electron launch, in case we learn anything new, and also just so it plays off of the Electron launch. As people are prepping for it, they can watch that and learn what they need to learn about the Electron launch. So, Trond wants to see the Saturn V, the Lego Saturn V. I'll have to show you guys that. Yeah. There we go. I think that's going to do it for me, guys. Yeah, the Electron video will be really cool. Space debris is on the list. A collab with Amy in the works. What I want to do next time in California, I want to do a live stream debate with Amy where I take on we'll do new space versus vintage space. I'll represent new space, she'll represent vintage space, our two expertises, and go head to head and have a curated, moderated live stream debate. That's what I want to do. Maybe we'll do it at the TMRO studios. I think it could be a lot of fun. Yeah, so hopefully. There we go. Any plans for 100K? I don't know, guys, honestly. You know, I don't know. Maybe I'll just do a live stream. Thank you, guys. I don't really have any plans. I don't like when people try to do like those counter things when they get to a certain number. I'd rather just have a nice little bit of Macallan, and yeah, just maybe a little fire and sit and be like, yes. I don't know. I have no idea. So there we go. That's going to do it for me, guys. Put 100,000 satellites into space. That's funny. There we go. Oh, Toby, no, we have not found the winner of the space shuttle for 400 patrons. Thank you for reminding me, because I have to send that out. I'll get that spreadsheet out to Carl right now. That's a great idea. Thank you for reminding me. That's going to do it for me, guys. Thank you. And Discord channel, I'll stick around and we're going to talk a little bit more about some things, so get ready for that. But thank you guys so much for joining me on this launch live stream. Hopefully you can re-watch and hopefully learn a few more things about the Atlas V and any things about space. And if you have any questions, make sure and let me know. I put a poll up on YouTube talking about upcoming videos and things like that. Also, if you want to become a Patreon member and join our Discord channel or exclusive subreddit to help talk about upcoming videos and voice your opinions there, patreon.com/everydayastronaut. Thank you so much to those patrons that are in here and the sponsors on YouTube. That stuff means a lot. It helps me keep going. It makes this stuff possible. So thank you guys so much. That's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Bye, guys. I think we all dreamt about going to space when we were kids. But when the space shuttle program ended in 2011, I discovered a void in my life. That emptiness led to a newfound obsession with space. A few years later, I wound up bidding on a Russian spacesuit as a joke. When the box arrived at my doorstep, my friends asked, "What are you going to do with a spacesuit?" The answer? What can't I do with a spacesuit? That's how Everyday Astronaut was born. Since then, the suit hasn't left my side. It's even gone around the world with me. From remote villages in Myanmar, rockets and spaceships, to beautiful fields in Norway. I'm fighting a cow to get a picture right now.
Here I am on vacation in the beautiful Norway with my beautiful boyfriend.
I even proposed to my wife in the suit at Machu Picchu in Peru. These days I work with leaders in the space industry to create fun and inspirational content. I've even been invited to different NASA facilities across the country, all for the sake of sharing my excitement with the world.
Hey there, it's me, Tim Dodd, the Everyday Astronaut. Now, I'm not sure if you're aware, but NASA is doing some incredible...
This is church for us space nerds. This is where Gene Kranz was sitting when people first met on him. This is with permission. I still don't know how. I love that I'm standing on something that says urine bags. This thing's gonna fly like a cat and eat. Whatever that means. That dog's gonna have a sore throat by the end of the day, I'll tell you that. Especially once he tries to explain to his friends that he just saw an astronaut flying majestically through the sky for an hour. This thing has officially become the bane of my existence. Everyday Astronaut's mission is to bring space down to Earth for everyday people, to communicate science through humor and imagination, but most importantly, to spark your curiosity, to want to find your place in the cosmos. Join my adventures as I seek to find out why exploring space is important, inspiring, and quite frankly, really, really neat. Show your support by visiting patreon.com/everydayastronaut.